Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss some tough numericals based on electrochemistry. Last class I discussed numericals based on Nernst equation, that was medium, but today's I am going to discuss tough numericals. Now I am reading the question. The specific conductance of 4 electrolytes in per ohm per centimeter are given below. Which one offers higher resistance to the passage of electric current? First option 7.0 into 10 to the power minus 5. Second option 9.2 into 10 to the power minus 9. Third 6.0 into 10 to the power minus 7. Fourth 4.0 into 10 to the power minus 8. Keep pen and paper with you, then it will be easy for you to solve the numericals. Again, one more time, reading the question. The specific conductance of 4 electrolytes per ohm per centimeter are given below. Which one offers higher resistance to the passage of electric current? First option 7.0 into 10 to the power minus 5. Second option 9.2 into 10 to the power minus 9. Third 6.0 into 10 to the power minus 7. And fourth 4.0 into 10 to the power minus 8. Just you think it. Despite it is tough, you can solve it very easily within 1 minute, provided you should have concept of the subject. It will not take more time. Just to think. After that, I will give you hint or explanation. Just to think it. Now I am giving you hint. See, in question what they are asking and what is given. Just you consider that things. The specific conductance of 4 electrolytes in per ohm per centimeter are given. Means specific conductance are given for 4 electrolytes. You have to answer which one offers higher resistance to the passage of electric current. If you pass the electric current, which will out of 4, which electrolytes will offer higher resistance? Then here you have to, all 4 options you have to observe. Why you will observe? You know that conductance and resistance both are inversely proportional. If resistance is more, conductance will be less. On that basis, now you think out of given 4 options, which value is conductance offers higher resistance. A specific conductance have given Then according to the given option, you have to find out whose resistance is more. Okay. A specific conductance value is given. Correct? You have to find out which one offers higher resistance to the passage of electric current. Conductance is given. Then which conductance is more? First you find out. Now which one conductance is less, that you find out. Then you can tell about the resistance. It will be reverse. Option is 7.0 into 10 to the power minus 5. Second is 9.2 into 10 to the power minus 9. And this third one is 6.0. 6.0 into 10 to the power minus 7. And fourth one is 4.0 into 10 to the power minus 6. Then you just find out, observe, whose resistance, higher resistance, you have to find out. Which one offers higher resistance to the passage of electric current. Think it. Now I am telling you explanation. Okay. Here just you see option B, that is the correct. How option B is correct? Now I am telling you. That is option B is 9.2 into 10 to the power minus 9. This is the out of 4 option. All are the conductance value. Then least value is 9.2 into 10 to the power minus 9. See, just all you can see. 10 to the power minus 5, that is more, highest. 10 to the power minus 7, that is again further more. Out of this 4, you will see that 9.2 into 10 to the power minus 9, that is the least. That is the least conductance, 10 to the power minus 9, because one is in 10 to the power minus 5. And other three are more, 10 to the power minus 5, 10 to the power minus 7, and fourth option is 10 to the power 8. Only second option, that is a 10 to the power minus 9. That is the least conductance. Least conductance, the specific conductance is least, 9.2 into 10 to the power minus 9. All are more, 10 to the power minus 5, 10 to the power minus 7, 10 to the power minus 8. Only option B is least. Least conductance means this solution will offer highest resistance, because a specific conductance, or simply conductance and resistance, are inversely proportional. Okay, you know K is equal to 1 upon R into L upon A. Means resistance is, here L upon A for a cell is fixed, cell constant. L upon A is called cell constant. Then you can write R is inversely proportional to 1 upon K. Resistance is inversely proportional to a specific conductance. R is proportional to 1 upon K, means inversely proportional to K. Hence, if conductance is less, then resistance will be more. Hence, option B is correct answer. Now, next question I am telling you, that is the question number 450. 449 I told you. Now next question 450. Now I am reading. A galvanic cell is set up from a zinc bar weighing 100 gram and 1.0 liter of 1.0 m copper sulfate solution. How long would the cell run if it is assumed to deliver a steady current of 1.0 ampere? It is given atomic mass of Zn is equal to 65. It is given. First option is 1.1 hour. Second option 46 hour. Third option 53.6 hour. Fourth option 24.00 hour. Again, I am reading one more time question. Okay, just to listen carefully. And already I told you, keep pen and paper with you. Only then you can solve the numericals. Again, I am reading the question. Question number 450. A galvanic cell is set up from a zinc wire weighing 100 gram and 1.0 liter of 1.0 m copper sulfate solution. How long would the cell run if it is assumed to deliver a steady current of 1.0 ampere? Atomic mass of zinc is equal to 65, which is given. First option is 1.1 hour. Second option 46 hour. Third option 53.6 hour. Fourth option 24.0 hour. Just to think. How will you solve? Just to think. After that, I will give you hint or explanation. Just to think. You can solve it within 1 minute. Now I am giving you hint. See, 100 question you have to understand. A galvanic cell is set up. How it is set up? Then they have used zinc bar, just like a zinc rod. Its mass is 100 gram and it is dipped in 1 liter solution of copper sulfate. And copper sulfate strength is given 1.0 m. 1 m you can tell. This rod, zinc rod, 100 gram zinc rod is dipped in the copper sulfate solution having a strength 1 m and its volume is 1 liter. Correct? I think you have understood the question. Rod is dipped in the copper sulfate solution, 1 liter copper sulfate solution. In that, this rod is dipped. Okay, and copper sulfate strength is 1 m. 1.0 m means 1 m. Now you have to calculate how long would the cell run if it is assumed to deliver a steady current of 1.0 ampere. Means current is flowing, 1 ampere current is flowing. Okay. Atomic mass of zinc is given 65. Then here, first to find out 100 gram zinc sulfate is there. Then 100 gram zinc sulfate means how many moles? How many moles? Then for that it is given in question atomic mass. Zinc atomic mass is 65. Then 100 divided by 65. Then you will get 1.53 mole. 100 divided by 65, that is 1.53 mole. You have divided by atomic mass. Mass divided by atomic mass. Then you got mole, number of moles, that is 1.53 mole. Now just first work you have done. Second, 1 liter of 1 m copper sulfate solution contains how many moles of copper sulfate? 1 liter of 1 m copper solution contains how many moles of copper sulfate? Because it is 1 m copper sulfate, then obviously 1 mole. 1 mole, 1 liter of 1 m copper sulfate solution contains 1 mole of copper sulfate. Correct? Reaction you know, because you have that in question cell is there. Zinc rod is dissolved in copper sulfate. Then it formed cell, the Zn plus copper sulfate. Reaction now it will take zinc plus copper sulfate. It will give zinc sulfate plus copper sulfate. Correct? Copper sulfate here you can see. Copper sulfate is the limiting reagent. That is important here. In reaction, in Zn plus copper sulfate, ZnSO4 plus copper, here copper sulfate is the limiting reagent. Why limiting reagent? Because zinc is 1.53 mole, but copper sulfate is only 1 mole. Hence, it means complete copper sulfate will react. Only 1 mole copper sulfate is there, but zinc is 1.53 mole. Correct? Then copper sulfate is the limiting reagent. Then now after that, this is the actually second step you have to consider. Then to deposit completely 1 mole of copper, electricity required will be how much? 2 into 96,500 coulomb. Correct? Each electron you have to consider, because in this reaction copper sulfate Cu plus 2 plus is there, it will take 2 electron, then it will convert to copper. 2 electron, then in 1 electron, for 1 electron you can tell that electricity will be 96,500 coulomb. Then for 2 electron, 2 into 96,500 coulomb. Then total to deposit completely 1 mole of copper, because 2 electron is involved, you will require 2 into 96,500 coulomb, because 2 electron is involved. Then total electricity required is 2 into 96,500 coulomb. Then now time you have to calculate how much time it will take. Then you know that T is equal to Q upon I, ampere current. Correct? Q is equal to I into T. This formula, this is the third step. Third step you require. Correct? And concept you require that is that to deposit completely 1 mole of copper, 2 into 96,500 coulomb is required. That is the third concept. Third and fourth is that formula you are using now. Q is equal to I into T. Q is quantity of electricity. T is equal to time. I is equal to ampere, means current. Correct? Then you were supposed to calculate how long would, time you have to consider, how long would the cell run if it is assumed to deliver a steady current of 1 ampere, means I is equal to 1 ampere. Then Q is equal to I into T, then T is equal to Q upon I, then I is equal to 1 and Q is equal to 2 into 96,500. Then this is actually second, total second, because ampere is I is equal to only 1, hence 2 into 96,500 second. That you can convert it in hour by dividing it by 3,600. 60 into 60, in 1 minute 60 seconds are there, and in 1 hour 60 minutes are there. Then total second how much? In 1 hour 60 into 60, 3600. Then this second you convert in hour by dividing it by 3600. Then after dividing you will get 53.6 hour. 53.6 hour. Hence third option 53.6 hour is correct. Here to solve this numericals you have 4 concept was required here. That's why it is tough. 449 was also tough because, but not like this. This is more tougher than first one, 449. But their concept was required. In all tough numericals, you have to think from every angle. Now next question I am reading. 451. Question number 451. I am reading question. An electrochemical cell is set up as follows. Platinum, actually it is given hydrogen gas electrode. You know that in hydrogen gas electrode platinum is required and its pressure is given 1 atm. Then hydrogen gas electrode is given platinum H2 and H2 pressure is 1 atm and it is dipped in 0.1 m HCl. This is actually hydrogen electrode. Always hydrogen electrode means one platinum wire will be there, hydrogen gas will be passed and keeping pressure 1 atmospheric pressure, and this hydrogen gas is passed in 0.1 m HCl through platinum. Correct? This is the hydrogen gas electrode. And other electrode is acetic acid is dipped in hydrogen electrode. Okay, means 0.1 m acetic acid. In this 0.1 m acetic acid, hydrogen electrode is dipped. 2 hydrogen electrode you are using. First hydrogen electrode in the beginning, that is dipped in 0.1 m HCl, and second hydrogen electrode is dipped in 0.1 m acetic acid, and both electrodes are separated by salt bridge. Then now you have to answer. EMF of this cell will not be zero. EMF of this cell will not be zero because 4 option is given. First option is the pH of 0.1 m HCl and 0.1 m acetic acid is not the same. This is first option. Second option is given. Acids used in the 2 compartments are different. Third option. EMF of a cell depends on the molarities of acid used. And fourth, the temperature is constant. Correct? You have to select any one. Again, I am reading question one more time. An electrochemical cell is set up. Then this electrochemical cell is set up by using hydrogen electrode. 2 hydrogen electrode. 1 hydrogen electrode is dipped in 0.1 m HCl and hydrogen gas is 1 atmospheric pressure and HCl concentration is 0.1 m. Second hydrogen gas electrode is dipped in 0.1 m acetic acid and pressure is same, 1 atmospheric pressure, and both electrode, because same electrodes are there, then both are using platinum. Both are separated by salt bridge. You have to tell about the EMF. EMF of this cell will not be zero. It will be not zero. Why? Because you have to answer any one. First option. The pH of 0.1 m HCl and 0.1 m acetic acid is not the same. Second, acids used in the two compartments are different. Third, EMF of a cell depends on the molarities of acids used. And fourth, the temperature is constant. You think it will also take less time. 30 seconds is sufficient if you have concept. Just to think it. After that, I will give the hint or explanation. Think it. Now I am giving you hint. First I will tell the answer. Actually option 1 is correct answer. Option A. You have to find out EM of this cell will not be 0 because first option is correct. pH of 0.1 m HCl and 0.1 m acetic is not the same. Both solution pH is not the same. That is the correct I can say reason. Okay. Here you will see that E cell is not equal to 0 because hydrogen ion concentration is not the same in 0.1 m HCl and 0.1 m acetic acid. You know that pH depend upon hydrogen ion concentration. Then HCl is a strong acid and acetic acid is weak acid. HCl will produce more H ion. Acetic acid will produce less ion. Correct? Because HCl is stronger than acetic acid. That is the main reason. Okay. Now next question I am reading. Question number 452. Using the following electrochemical reactions, chemical reaction is given. AgCl solid plus one electron. It gives Ag solid plus Cl1 minus aqueous, and its standard electrode potential is given plus 0.222 volt. Okay, 0.222 volt it is given. Other reaction is there, that is both are actually reduction reaction. Again Ag plus aqueous plus one electron, it is giving Ag solid, and for this standard electrode potential is given plus 0.799 volt. The value of KSP for AgCl at 298 K will be. 4 option is given. First, 1.0 into 10 to the power minus 8. Second, 1.7 into 10 to the power minus 9. Third, 1.7 into 10 to the power minus 10. Fourth, 1.7 into 10 to the power minus 11. Okay. Again one more time question I am reading. Okay. Just to listen carefully and think it. First listen one more time question I am reading. Using the following electrochemical reactions are given. First reaction is AgCl solid plus one electron. It is giving Ag solid plus Cl minus aqueous, and its electrode potential is plus 0.222 volt. Second reaction, Ag plus aqueous plus one electron. Product is Ag solid, and its electrode potential, standard electrode potential is given plus 0.799 volt. The value of KSP for AgCl at 298 K will be, means Kelvin, will be first option 1.0 into 10 to the power minus 8. Second option 1.7 into 10 to the power minus 9. Third option 1.7 into 10 to the power minus 10. Fourth option 1.7 into 10 to the power minus 11. Just to think it seriously, correct? Think it, after that I will give hint or explanation. Now I am giving you hint or explanation, whatever you understand. Here you have to understand the question first. You have to calculate KSP. Okay, so it is based on solubility product, because this numerical is based on solubility product. You have to calculate solubility product of AgCl at 298 Kelvin. You have to calculate. For this purpose, two reaction is given. Then you know, for the to get the solubility product constant KSP, you required, you can say, one reaction. One reaction means how it is giving AgCl. Ag plus C plus Cl minus, it will give AgCl. This is actually, this reaction you have to use. Correct? You have to obtain this reaction. You have to obtain by using given two reaction. Two reactions are given. By the using these two reaction, you have to find that AgCl, you know that it will dissociate and it will give Ag plus Cl minus. That reaction is required. Then you know that after writing this, you will get that these things. After this equation, after this reaction, you can tell AgCl solid, you know that in water it dissociates. It will give, after dissociation, it will give Ag plus aqueous, Cl minus aqueous. This reaction you have to obtain from the given two reaction. How you will get? Then by subtracting second equation from the first equation. Value also you have to subtract. Standard electrode potential, that also you have to subtract. Okay. Then if you will subtract second equation from first equation, then you will get after the subtraction, you will get AgCl is giving Ag plus Cl minus, and E you will get standard E, you will get that is equal to minus 0.577 volt. Okay, given reaction, just I am telling you again that AgCl plus electron, it is giving Ag solid plus Cl minus, and value is E, standard E value is 0.222 volt, and second is Ag plus aqueous plus 1 electron, it is giving Ag solid. Correct? And E standard value is plus 0.799 volt. 0.799 volt. Then second minus 1. Then what will happen? Ag will cancel. Electron will cancel. Correct? And this, that also you have to deduct. Minus because you will do. Then after reversing 2 minus 1 you will do, then you will get the standard electrode potential for this reaction. AgCl is giving Ag plus plus Cl minus. Then its value will be minus 0.577 volt. This is the first step. Now after that, just you apply the Nernst equation. The Nernst equation, you know, E is equal to standard E minus 0.0591 divided by N. Here N is equal to how much? Here in this reaction, here this N value, because it is the silver ion, only one electron is involved. Okay. Then now here just to apply the Nernst equation, then 0.0591 divided by N log Ag plus Cl minus divided by AgCl, means products, concentration of products, molar concentration of products divided by molar concentration of reactant, that is the AgCl solid. For that value is, you know, its value is 1. Its value is 1. Then now here putting the value of AgCl is equal to 1, and because your K value you want to calculate, then what is the condition? That this should be at equilibrium. At equilibrium E will be 0. This is the third concept. After applying Nernst equation, third concept, that E must be 0 at equilibrium position. Then now here you will get, that is the in this equation, Nernst equation, E is equal to E0. Correct? Then a standard E value you can calculate. Actually a standard E value will be what? 0.0591, because N is equal to 1, small n, number of electrons is 1. Then 0.0591 log concentration of silver ion into concentration of chloride ion. Correct? Then here molar concentration of silver ion, molar concentration of into molar concentration of chloride ion. Molar concentration of silver ion into molar concentration of chloride ion, that is actually Kp, log Kp. Then now here electrode potential you have calculated after subtracting second minus 1, minus 0.577. Then in the place of standard E you write minus 0.577, that is equal to 0.0591 log KSP. Kp means here KSP. Then you can calculate log KSP is equal to what? Just you, because it is very clear, out of 3, 2 you are knowing. Means a minus 0.577 is equal to 0.0591 into log KSP. Then log KSP is equal to minus these things. After solving you will get minus 0.577 divided by 0.0591. Correct? You will get after solving KSP value, after dividing minus 0.577 divided by 0.0591, you will get minus 9.7631. Minus 9.7631 you will get. That you can write, you can say 10 var minus 2369, or you can take anti-log of minus 9.7631. Log KSP value are knowing, then KSP value anti-log you can take. Then, or you can write 10 var 0.2369. Correct? Then after that, now we are knowing log KSP is equal to 10 var 0.2369. Then KSP value we will calculate by taking anti-log 1.726 into 10 to the power minus 10. Correct? Log KSP value are knowing, that is equal to 10 to the power 10 bar 0.2369. Then KSP value can calculate by taking anti-log. Then its value will become 1.726 into 10 to the power minus 10. It will take, if your concept is clear, then you can solve it fast, because here also 2, 3, 4 concepts are required. Anti-log value chart will be given, correct, or some hint will be given. Here no hint, nothing is there, but this is not very difficult, that you can KSP value, sometimes charts will be provided in exam time, then that quickly you will calculate the KSP value. Its value will become 1.726 into 10 to the power minus 10. And its correct option is, option third, 1.7 into 10 to the power minus 10. Okay, it will take a little more than 1 minute, or roughly 1 minute it will take that time. You have to do very fast in exam time. Okay. Now next question I am reading. All questions are tough question. Okay, now I am reading the question. Next question. Question number 453. Which of the following is incorrect about transport number? First option, it decreases with increase in concentration. Second option, it may increase or decrease with increase in temperature. Third, it is never zero. Fourth, it is different for chloride ion in 0.1 mHCl and 0.1 m NaCl solution. Again one more time I am reading the question. Which of the following is incorrect about transport number? First option, it decreases with increase in concentration. Second, it may increase or decrease with increase in temperature. Third, it is never zero. Fourth, it is different for chloride ion in 0.1 mHCl and 0.1 m NaCl solution. This will take less than 30 seconds. If your concept is clear, it will take less than 30 seconds just to think. After that I will give hint or explanation. Okay, just to think. Now I am giving you hint. Its correct option is third option. It is never zero. It is never zero. All you can say, other three are correct. Means the first option, it decreases with increase in concentration. That is correct. It may increase or decrease with increase in temperature. That is also correct. And last option, it is different for chloride ions in 0.1 mHCl and 0.1 m NaCl solution. That is also correct. Okay. Then what is the incorrect? Then option C, it is never zero. This is answer is this C only. It is never zero. This is incorrect about the transport number. Now I am telling you why. Okay. Then here you can see transport number can be 0. Transport number can be 0. That is, at high concentration of cadmium iodide CdI2 solution, cadmium ion Cd2 plus may have 0 or even negative transport number due to formation of complex ion CdI4 2 minus. This is the main reason. Okay, transport number can be 0. Okay, example I am telling you, at high concentration of cadmium iodide CdI2 solution, cadmium ion Cd2 plus may have 0 or even negative transport number. Why? Due to formation of complex ion CdI4 2 minus. Hence correct answer is option C. It is incorrect. Incorrect about the transport number is it is never 0. Option C is correct answer. Now next question I am telling you. Question number 454. Equal quantities of electricity are passed through 3 voltmeters containing FeSO4, Fe2SO4 whole 3, and third one is FeNO3 whole 3. Consider the following statement in this regard. First statement is the amount of iron deposited in FeSO4 and Fe2SO4 whole 3 are equal. Second statement, the amount of iron deposited in FeNO3 whole 3 is 2/3 of the amount of iron deposited in FeSO4. Third statement, the amount of iron deposited in Fe2SO4 whole 3 and FeNO3 whole 3 is equal. Now we have to tell of these three statements. 4 option is given. First, 1 alone is correct. Second option, 1 and 2 are correct. Third option, 2 and 3 are correct. And fourth, 3 alone is correct. Again one more time I am telling you. Listen carefully. Equal quantities of electricity are passed through 3 voltmeters containing FeSO4 first, second Fe2SO4 whole 3, third FeNO3 whole 3, FeNO3 whole 3. It has passed through 3 voltmeters. Now 3 statements is given. Consider the following statements in this regard. First, the amount of iron deposited in FeSO4 and Fe2SO4 whole 3 are equal. Second statement, the amount of iron deposited in FeNO3 whole 3 is 2/3 of the amount of iron deposited in FeSO4. Third statement, the amount of iron deposited in Fe2SO4 whole 3 and FeNO3 whole 3 is equal. Of these 3 statements, now we have to tell. First option, 1 alone is correct. Second, 1 and 2 are correct. Third, 2 and 3 are correct. Fourth, 3 alone is correct. Just you think, and after that I will give you hint or explanation. Just to think. This question you can answer within 1 minute easily. Now I am giving you hint. Here 3 statement is given and you have to read the question very carefully. Equal quantities of electricity are passed in 3 solutions. Correct? First solution is FeSO4, second solution is Fe2SO4, third is FeNO3, means through 3 voltmeters. 3 statement is given. First statement given that amount of iron deposited in FeSO4 and Fe2SO4 are equal. Second, amount of iron deposited in FeNO3 is 2/3 of the amount of deposited in FeSO4. And third statement, the amount of iron deposited in Fe2NO3 and FeNO3 is equal. Correct? Then now you have to tell about this statement. Considering these 3 statements, which one is correct? Okay. Then now for this, I am telling you what will be the correct option. First I will tell the option, then explanation I will tell you. Actually, its correct option is third option. Second and third are correct. Second and third are correct. How? Now I am telling you. Okay. Reaction you can see. Fe2 plus 2 electron, it will give Fe. That is a common reaction, a reduction reaction. Fe2 plus 2E, it will give Fe. Here 2 electron is involved. Now one more reaction, Fe3 plus 3 electron. Here 3 electron is involved, it will give Fe. That on considering these 2 reaction, reduction reaction, you can answer Fe2 plus 2 electron, that is giving Fe. And second reaction is Fe3 plus 3 electron is giving Fe. Both are reduction. Then you know that 1 gram equivalent, for 1 gram equivalent 1 electron is required. You remember. Correct? Per electron you have to calculate. Per electron you have to calculate the weight. That is called equivalent weight per electron. This concept you have to apply here. Now I am telling you why option this C is correct. Statement second and third. Then now it should understand weights deposited are in the ratio of their equivalent weights. Okay, this is the main things. Weights deposited are in the ratio of their equivalent weights. Correct? Hence second and third are correct. Correct? Both reaction you have seen that Fe2 plus 2 electron in whenever Fe is in plus 2 state, then 2 electron. If 3 state, then 3 electron. Then this second and third statement, that is the amount of iron deposited in FeNO3 it means what? FeNO3 means you are talking about Fe3 plus. NO3 is telling about Fe3 plus. Fe is in plus 3 state. Correct? And in FeSO4 is 2 minus. It means Fe is 2 plus. Hence, just you will consider the equivalent mass. Then you will find equation second is right. Amount of iron deposited in FeNO3 is 2/3 of the amount of iron deposited in FeSO4. In FeSO4, 2 electron is involved, and in FeNO3 3 electron is involved. Then this second statement is correct, and third you can see a statement, amount of iron deposited in the Fe2SO4 Again here you can see Fe2SO4 Fe is in plus 3, and second is FeNO3 Here also Fe is in plus 3. Correct? The amount of, third statement is the amount of iron deposited in Fe2SO4 whole 3 and FeNO3 whole 3 is equal. This is correct, because in both salts, in both electrolytes, Fe is in plus 3 state. Hence, obviously, they will deposit equal amount. And second and third is correct. Okay. One more question I want to discuss. Question number 455. Okay. Now question I am reading. In an electrolytic cell, 1 liter of 1 m aqueous solution of MnO4 1 minus is reduced at the cathode. The quantity of electricity required so that the final solution is 0.1 m MnSO4 2 minus will be first option 0.1 F, second option 1 F, third option 10 F, fourth option 100 F. F means Faraday. Again I am reading one more time. Listen carefully, question is tough. In an electrolytic cell, 1 liter of 1 m aqueous solution of MnO4 1 minus is reduced at the cathode. The quantity of electricity required so that the final solution is 0.1 m MnO4 2 minus will be first option 0.1 F, second option 1 F, third option 10 F, fourth option 100 F. Just to think, how will you solve these numericals? Think it seriously. Actually 10 seconds is sufficient to think. If you think in a proper way, then only can you solve it within 1 minute. Think it, I will give hint and or explanation. Now I am giving you hint. See here that reduction reaction MnO4 is reduced according to the question. Okay, at the cathode. Then M reduced means it has accepted 1 electron at least. Correct? Because now it is converted to MnO4 2 minus. Finally, you have to see. You have to find out the quantity of electricity required so that the final solution is 0.1 m MnO4 2 minus. Then here reduction has taken place, reduced at cathode means MnO4 has taken 1 electron. Then after taking this electron, MnO4 1 minus will convert to MnO4 2 minus. Correct? Because it has absorbed, it has taken 1 electron. Now it converted to MnO4 2 minus. Then that's why in question it is asking the quantity of electricity required so that the final solution is 0.1 m MnO4. Then now you have seen that now it is converting to MnO4 2 minus. From MnO4 1 minus it converted to MnO4 2 minus by taking 1 electron. Now just this is the first step. Now second step you have to consider 1 mole of MnO4 whole 2 can be obtained passage of 1 Faraday. That you know, that is the according the definition. Okay, 1 mole of MnO4 2 minus, because 1 electron is involved. Just to think, only 1 electron. Then 1 mole of MnO4 2 minus can be obtained by passing 1 F, because 1 electron has absorbed. Then you have to pass, you will get it, 1 mole you will get by passing 1 F, 1 Faraday. Then For 0.1, according the question you want 0.1 mole. 0.1 mole. Then how much you will require? These things current. Then 0.1 mole will be obtained by passage of 0.1 F. From 1 F you are getting 1 mole. 1 mole MnO4 2 minus 1 mole. Then for 0.1 mole 0.1 F, 1 F is giving 1 mole MnO4 2 minus. Then you want 0.1, then that you will get by 0.1 F. 0.1 F, 1 by 10, 0.1 F Faraday. Hence correct option is option A, 0.1 F. See, this question will take less than 30 seconds to solve it if your concept is clear. Okay. Today I am stopping only here. Next class again I will continue with hard numericals only. Thank you.